As you can see from the title at the top, we're talking about errors and power. Now, in the past, when we've talked about error, we've been talking about like standard error, the average distance of every mean, sample mean from the entire mean, like standard deviation, or we talked about other errors like sampling error. Like, so when you do sampling and you get an X bar value, we know that that X bar is very, very unlikely going to equal the actual mu, so it's going to be off by a little bit, and we're okay with that as long as we're using proper technique. So those errors are, we did something and we're just a little bit different than what it should be, and that's fine and that's normal and that's okay. Now we're going to talk about error in terms of we actually made a mistake. What we have is I have these two hypotheses over here. We're going to look at those and say, okay, if I'm testing that the average is, so this would be my distribution of X bars, we'll assume I went through all the conditions and I have a sampling distribution that's normally distributed. And I want to find out the likelihood that what I'm testing is less than 12. So that's a right-tailed test. And let's say that this is 8%. So we did this and we got 0.08, or 8%. So what we're saying is that if we assume the null is true, if we assume that mu equals 12, then the results I got when I did this assessment was that these results would happen 8% of the time, or so interpreting the p-value. The likelihood that the result I got, so let's say I got an X bar of some number, all right, the likelihood that this happened is, assuming that the null is true, it should only happen 8% of the time by chance. All right, so is 8% likely to happen or not likely to happen? Since 8% is not that unusual, we're going to say that the difference that we saw here could have been just due to chance. All right, in this area out here, my p-value is also called alpha, which is the probability of a type 1 error. So that is, what if I reject type 1 error? All right, type 1 error is I reject the null incorrectly. I reject the null incorrectly, which means I rejected the null and I shouldn't have. So that means, in this case, I rejected the null and there was an 8% chance, if the null was true, that the results I have would have happened. All right? So that's actually the same as making an incorrect. So we're saying, what's the likelihood that I rejected the null? 8%, because that's what I found for my p-value. What's the probability that I did it wrong? Well, it's 8% because there's an 8% chance that I could have been in that result. All right. A type 1 error is alpha. It's the area of rejection in this case. Now over here, if I'm testing for negative, less than, let's say it's here, and then we're going to, what if, this is a big what if later on we found out that mu actually is 10? So we were testing, the alternative was that we were testing, that's an A, for mu less than 12. Is mu less than 12? Yes, we found out later on that mu is actually 10. 10 is less than 12. So based on the way I did my test before, all right, if I am out here, lower, in this case I'm greater than 10, but if 10 was the actual probability, or excuse me, if 10 was the actual lower value for mu, I'm going to find out, well, what's the probability that maybe I did not reject the null? So remember, in this case, with my regular graph from my original data, if I'm over here, I reject. If I'm in here, I do not reject the null. All right, so a type 2 error is I am in the do not reject the null region, and I'm wrong. I should have rejected the null. All right, so if I should have rejected the null, but I did not reject the null, that's a type 2 error. And the probability of a type 2 error is beta, probability type 2, is the Greek letter beta. So what's the likelihood that that happens? Well, in order to know that, I need to know what the actual mu really is. So that's why it's not something that we're actually going to calculate in class, but you have to understand where it's coming from, and I'll tell you a couple of things that you have to know. So if the actual mu is 10, it's less than 12, and I did not reject the null, that means if I take this basic area here and translate it down onto the other graph, that is this area. So if indeed the mean is less than 12 and it's 10, this area is the zone I was in this new graph, knowing that the new mu is 10, less than 12. This is beta. All right. So again, unless we know this value of 10 and no other characteristics about the graph, we can never actually calculate beta out by hand. If we know alpha, that does nothing about it. All right. Now, what happens? How can I make beta smaller? How can I make beta smaller? All right. If I want to reduce its size, then I go like this. Make a green line. And then transfer that up. Pretend that's a straight line. And then it goes up there. What did that do to my original graph? It made this area larger, which is alpha. So there is a relationship. If I leave everything else the same and I increase alpha, beta decreases. So if I have a larger type 1 error, then I have a lesser type 2 error. All right, that is if I leave everything else the same. All right. The other thing I want to explain here, and I'll go back to blue, pretend we're in the blue again. So this zone over here is what is called power. That is, it corresponds with this blue area up here, which is alpha, the likelihood of rejecting the null, if we assume that 12 is true. Knowing that 10 is true, down here, power is the likelihood of correctly rejecting the null. So power is the probability of correctly rejecting the null. And in this case, well, in every case, power is equal to 1 minus beta, because beta was the likelihood that I did not reject the null correctly or incorrectly. So the dotted versus the dashed in this lower graph. All right, so power, and then go back to the green line. Green line is, if I want to decrease beta, we'll see that that increases power. Increasing power is the likelihood of correctly rejecting the null. And one thing I can do to increase power is to increase alpha. So increasing alpha increases power. Increasing alpha decreases beta. All right, and there's one other thing that you can do that will increase the power of your function. That is the likelihood that you can correctly reject the null. All right, and it's intuitive a lot of times when we finally say it, but it's this idea of, let's say that it's not 12 to 10, maybe it's 12 to 11. So they're actually really close. So a closer difference that we're trying to detect, how can I detect a smaller difference? And the answer is, well, I sample more. Unfortunately, it's like the answer to a lot of our questions. How can we be more accurate? How can we do more, how can we be more precise? I mean, a narrower confidence interval, increase the sample size. How can I have more power? I increase the sample size. Increasing power is increasing my ability to correctly reject the null. All right. Last thing I want to say here with respect to power and error is this. No matter what you do in statistics, now we could look at something and we can, if we sampled enough data, we could determine that 11.5 is indeed less than 12. If the real mu is actually 11.5, I could just, find a way to reject the null and accept the alternative that that the mu is less than 12 when we know that it's only 11.5. So it's only a small difference. All right. I do that by having more and more in my sample size. But if I am going to increase my ability to be statistically significant, that does not mean that that difference is practically important. There are some things that are just minute differences that we're going to be able to test and see, yes, there is a difference. And then we look at the reality and say, it doesn't really matter. So much is part of this is involved in the idea of context. You have to build the context in. And most of the questions that we go through will say, first off, describe what a type 1 error. So first, just memorize type 1 error is I reject the null and I shouldn't have. And then insert context. I decided that the average is less than 12, the average something amount of soda in a can is less than 12 ounces, when in reality it's not. All right, so what's a consequence of that? Well, I could start putting less soda in cans, and the consequence of that is people will get some cans that are significantly less than full. All right, that's not good. People are going to start to talk. And all right, what if it's not true? So what if it's a type 2 error? That is, I do not reject the null, and I should have. So I don't reject the null, and I don't say that it's less than 12, but in reality it is less than 12. Then in a case like that, I'd say, well, I'm underfilling my cans, and I wasn't able to determine that I was underfilling my cans. It gets back to that whole public perception of my company and having underfilled cans. All right. Looking at what's going on, putting it in context, then making decisions about which one's better and which one's worse. All right. So this is the idea of type 1 error, type 2 error, and power. What I want you to do, again, in the reflection response, not just the notes, but in there, indicating what are the two things that you can do, what are the two things that you can do to increase power. List those in there, and then also, nope, that's it. Just do that for now. Put that in there, and I'll see you in class.